We have Rafiq Ahmad, an associate professor in the Department of Mechanical Engineering at the University of Alberta, who will share insights on revolutionizing industry through smarter and sustainable additive manufacturing. Give out applause to Dr. Ahmad.
Thank you very much. Good morning, everybody. So today I'm going to talk about revolutionizing industry with smarter and sustainable manufacturing systems. I'll be giving some examples project at the end, but in the beginning I want to just give you a kind of a general message on smart and sustainable manufacturing, what this is. So I'm coming from University of Alberta, which is in the middle of nowhere. It's one of the coldest places on earth. If you want to experience minus 45-degree temperature, then please do visit us. We have many opportunities on different projects, which we'll be discussing as well. So let's start with my quick introduction. I am actually associate professor in the mechanical engineering department, and I'm also faculty associate in the Nasri School of Building Science and Engineering. My work revolves around smart manufacturing, sustainable manufacturing, but I also focus on smart construction, robotics construction, and also on the aquaponics systems. So I lead 2 labs at the University of Alberta. I'm just looking for the it doesn't work. So I lead 2 labs. One is called Smart and Sustainable Manufacturing Systems Laboratory, and the second one is Aquaponics 4.0 Learning Factory. So I'll start with this as some pictures from the lab. We have 21 researchers working with us. We have all the different types of technology related to smart and sustainable manufacturing. That is CNC machines, additive manufacturing technologies and polymers, robotics, and then also different new systems and technology which we develop in-house in the lab. So let's start with the introduction. I think everybody knows what additive manufacturing processes are. It's creating objects by layering materials on top of each other. That's kind of the basic definition. This is a general picture from one of our papers where you can see the different areas of research around additive manufacturing. So a lot of people, they call this or interlink it to the 3D printing technologies as well. So that's why you see in the literature both names exist, 3D printing or additive manufacturing. And if you look from the various aspects of project, we have seen lots of projects over these past few days. But if you look into the process, a lot of people are looking into mechanical testing, anisotropy, microstructures. People also look into the plastic recycling. The sustainability aspect is a very big one, and then also recycling aspects. So if you see, the smartness, sustainability aspects are quite important when it comes to additive manufacturing. A lot of people have been looking into it, and it has application all across the different sectors. Now, I also want to talk a little bit about Industry 4.0 because that's something very important to us in our research. So if you don't know what Industry 4.0 is, which I should not be explaining it at Monterrey because you guys are well advanced in Industry 4.0, but still, I just want to give some highlights. So starting from the steam engines is the first revolution. The second revolution is more on the electrical systems. The third revolution more focus on the automation technologies. In the fourth revolution, which is based on cyber-physical technologies, where we talked about digital twins, we talked about sensors, we talked about data is the primary driver of this fourth revolution. And now we're going to the fifth revolution, which talks about human-centric design and sustainability aspect, which are also becoming more and more important in additive manufacturing. So when it comes to additive manufacturing, I think there are many technologies, but FDM is one important one. And if you just look into the global scale of additive manufacturing, in 2021, the global plastic AM only is valued at $787 million USD in 2021, and that's actually expanding exponentially in the plastic industry. So I'm just talking only about plastic here. I'm sure there's a lot of similar stats available on the metal side as well. When it comes to additive manufacturing application, for me, there are 4 major areas where I see the impact. The first one is on the left one on top, that's on the construction side. So you can see that people are talking about large-scale systems, a large-scale implementation of additive manufacturing technologies that's coming from Netherlands. On the right side, you also saw that in the previous presentation on laser cladding technology, where you are repairing different parts or kind of rebuilding certain aspects or functionalities into existing parts. So I'll talk about that as one project as well. On the bottom right side, you can see new products, new functionality, but people investigate more on the complexity of additive manufacturing systems. And on the left side, people also started looking into polymers and also recycling via additive manufacturing. So I'll talk about one project related to those as well. Okay, so on the additive manufacturing side, especially in the polymers and plastics, we are very interested in looking into different strategies for freeform surfaces additive manufacturing. We also investigate a lot on additive manufacturing 4.0 that is integrating different kinds of sensors and data capturing techniques and how do we actually reuse that into our systems. We are also interested in dissimilar materials integration. So this is just a simple example of that. How do you actually sandwich different materials and kind of test their performances? And that is not only true for polymers, but it can also be applied to metal additive manufacturing, and then kind of looking into the structure using hybrid technologies as well. This is just one other example on the same project where we looked into different integration of PLA, HIPs, and PLA again for different sandwich structure to see the performance of different materials. And then for most of these systems, you need smartness, which is available. So I want to talk a little bit about some ideas for thoughts that why and how we can actually integrate the smartness in additive manufacturing technologies. So the first one could be predictive maintenance, that is integrating IoT sensors that could be integrated into printing technology, so we can actually predict the health of different components which we are manufacturing, but also the health of the machine and reducing the downtime of the machine. We can also look into AI-based techniques for design optimization. If you want to create new design, there is new techniques like generative design which could be implemented as well. Real-time quality control is a big one, and we do a lot. We work a lot on that from various aspects. So integrating different sensors, computer vision, 3D scanners, there are many techniques where we can actually predict the real-time data from the system. Material innovation, we saw one presentation from Dr. Isaac this morning. How do you actually investigate AI using material investigation? We are not working on material side, but we work on mostly on the other sides of AI and smartness. And then last one is the data-driven insights into kind of the manufacturing process optimization, how to do the scheduling in additive manufacturing systems, and also kind of improve the quality for the future projects. So those are some ways how you can enhance additive manufacturing using smart technologies. The next one is the sustainability aspect. So how do you actually integrate sustainability is also an important point. Sustainable additive manufacturing refers to the practice of utilizing additive manufacturing technologies in an environmental and socially responsible manner. So it's mostly keeping in mind the environment and the society, and how do we actually kind of create a social environment using additive manufacturing. And this is becoming more and more important in the fifth revolution in industry. Again, on the material selection, you can start looking into which material you can select, how do you actually create a material which can actually be recycled later, both in the metal and the plastic industry. Energy efficiency is a big one, that how do you actually minimize the energy used to produce a particular part. That could be minimizing different waste in different ways. Then the next one is the reducing waste, particularly in the material side, that how do you actually minimize waste or minimize even waste of humans related to the additive manufacturing process. Then post-processing and finishing, we talked a lot about that yesterday as well from many examples in companies. And how do we actually minimize finishing processes so we can actually create a better part from the system directly. And then circular economy is a big one, that how do we actually enhance circular economy to recreate certain parts. So I'll talk more about that here. So circular economy is actually an economic model focusing on minimizing waste by optimizing the value of product, material, and resources to tackle it for the environmental degradation process. At the University of Alberta, in my team particularly, we focus on 3 areas on circular economy. One is recycling. I'll talk about plastic recycling in the next slide. Then repair and remanufacturing areas. So repair for metal parts mostly. How do we use laser cladding and wire arc additive manufacturing processes, and then remanufacturing in general. So this is just one particular example of how do we actually use additive manufacturing process for plastic recycling. So I'll just go quickly, and hopefully the video, play the video, and hopefully it works. Oops, sorry.
Introducing the Eco 3D printer. The material we can't seem to live without but lasts longer than 100 years. The material that swims in the oceans, clogs rivers, fills lands, and keeps our trash bags full. Plastic. It is used everywhere. In our cars, our food, packaging, homes, hospitals, airplanes. Infinite applications. It is calculated that only 3% of the plastic we consume is recycled in a closed loop. This ratio between consumption and disposal is a global issue that is becoming a threat for the environment and requires solutions for efficient reuse and circular economic strategies. On the other hand, 3D printing and additive manufacturing have become a revolutionary solution in many manufacturing applications where rapid creation of complex geometries, cost-effective customization, and higher energy efficiency can be achieved. Still, few solutions have been realized that can incorporate the use of recycled materials into commercial 3D printing systems. So for this exact purpose, we would like to introduce the Eco 3D printer solution. A novel hybrid 3D printer design that will increase plastic manufacturers' profits by reducing waste disposal cost. It will also create opportunities for businesses to reuse their waste and increase their cash flow by creating cheaper, rapidly developed second life products. To incorporate the recycled material into this novel hybrid system, it only requires the recycled material to be shredded prior to use. This helps to avoid the pains of reconverting the recycled material into filament, as direct diffused deposition can be done selectively in specific zones of the printed part. This smart way to reuse material waste can combine multiple materials at different reprocessing levels, expanding the freedom of design. This system will create new business opportunities for eco-friendly 3D printed products, promoting an efficient solution for the global plastic contamination problem. It will provide circular economy benefits for on-demand manufacturing companies, 3D printing farms, and prototyping services. The Eco 3D printer, the hybrid 3D printing solution for efficient manufacturing of plastic waste products.
So this was a video from last year. We have done a lot of experiments and kind of optimized the technology quite well. And we recently launched a company, spin-off company from University of Alberta called Additive, which one of the tech alumni postdoc is leading. And he's currently also exploring opportunities here in Mexico. The second project I want to talk about is laser cladding technology. So again, the same kind of technique we use, repair as or example or application for laser cladding technology and how we can actually optimize that. So laser cladding technology, we already talked about it in the previous presentation. So it's a layer by layer deposition to kind of enhance the properties of a particular product. The system which we use is mounted on a large-scale robotic system, which uses different kinds of sensors, for example, proximity sensors, vision sensors, and also laser scanning. We actually use that for large-scale systems and products, which comes from the oil and gas sector. The way the system works, we start with the scanning of a part. You can see from the top right side. So we start with the scanning of that part, and then we go to the next side. We generate kind of a triangulated mesh out of those point clouds. And once we have that, then we actually use that in our systems and software which we develop to kind of create all the tool path for the part. And once we know that exactly, then it's translated directly to the robot as a tool path, and the robot quickly goes and kind of do all the processing of in the laser processing, and we can actually check the part in a very autonomous way. Once the part is produced, we can also look into computer vision systems. On the right side, you can see where there, and the quick computer vision quickly detect where the damage was repaired and kind of also monitor if it's not repaired and if something else needs to happen. So it also quickly using AI techniques to kind of quickly adopt into identifying where the damages and kind of also qualifying the damage. On the left side, you can see another mobile platform robot, which we are currently working on. And the main idea of this robotic platform is to kind of use it, the same kind of techniques which we applied on an industrial scale system. Now we want to bring that outside into the field. So we are actually working on, and using the computer vision, we quickly detect where the damages are using AI techniques and kind of identify similar kind of processes on that. The next project, which is kind of could be used for new qualified products, or it could also be used for the same kind of principles that what we discussed in the repair side. We are also looking into kind of a wire cut additive manufacturing process using robotics, and we are kind of looking into how different materials join together, how different layers are performing, and how we can actually create a functional product out of it using additive manufacturing. So this is one of the ground engaging tooth which we are working on from the oil and gas industry is our partner. So the last one project is related to topology optimization. So we not only focus on the actual manufacturing process, but also kind of optimize the different designs and systems. So we work extensively on topology optimization, mostly from the additive and subtractive side. So we kind of combine the two systems together so we can create a better manufacturing process and manufacturing product in the end. So we do topology optimization for both hybrid manufacturing systems. And this is just one example for that. So we look into how do we actually qualify a material removal, for example, on the right side, and then also on the left side, we look into the additive manufacturing process. So I did not put a lot of examples on topology optimization, but this is an area where we look a lot into different types of texturing. We look into the microstructures. We look into the material access, and then we also look into the tool access for machining after the additive manufacturing process. Lastly, I want to talk a little bit about the future trends in additive manufacturing. There are many trends, but I will talk quickly about a few of them. Materials innovation, I talked earlier. Multi-materials is a big thing in both plastics and metal industry. Improved processes in speed and scalability, that's a big issue in additive manufacturing. So how do we actually enhance those in our systems? We need to really look into that. Printed electronics, bioprinting, those are two major industries which is heavily disrupted by these and will be disrupted in the future. Sustainability and circular economy, I talked a lot about that. It's one of the big things. AI and simulation, we need to heavily investigate on that, and even the presentation from this morning talked about that. And then we need to really tackle additive manufacturing as an industry-specific adoption, and then we should not forget about our human workforce and how to train our people at the end. Lastly, I got only last few minutes, so I just want to talk quickly about our current collaboration with the Monterrey. We have recently launched something called PyTech Academy. The main idea and focus about that is to kind of take whatever knowledge we develop at the university that is related to additive manufacturing, that is related to IoT devices, lean or AI, in robotics, and we kind of translate that to industry. And we do that by creating a combined platform, so anybody can join that, any industry can join, any group can join that. So we recently started that. We still have a vision, and we are still exploring a lot of opportunities. The main idea is to kind of look into the maturity scan. So currently we are developing a maturity scan which will be directly on the website for people. So the idea would be any industry can just go and kind of scan their industry and identify their pain points. Once they know what their pain points are, they can actually collaborate with any of these teams, internationally experienced teams, use some of their knowledge and develop certain technology, which could be common technology for many partners, and then we develop training around those technologies. So we have initially done some work already. The maturity scan is already developed. It's already implemented. We're still just working on the final website, which will be launched pretty soon, and then we have also done the training here at Tech the Monterrey here last year, and then we also did one training at the University of Alberta in June. In the future, we will actually establish similar kind of analysis. These are some of pictures which we did at the University of Alberta, and these are some pictures which we did here at Tech initially. So that's all for me, and I'm open to questions.
Thank you very much, Dr. Ahmad. We're going to start our session of Q&A. Here, thank you, Dr. Dora.
Yeah, thank you very much for your presentation. And I was wondering, what is the novelty in the Eco 3D printer, in the hardware?
The plastic recycling
Yes.
system. So that system is currently submitted for US patent. There is two areas where we have done some novel things. One is on the materials which we bring to the system. We can actually use either flakes, pellets, or the filaments, like a simple FDM system. So it's a hybrid system which can take any form of material, which makes it easy for people to use it for any application or any material which has come in. The second innovation is related to plastics. So we can integrate any type of plastic. It can melt and print any type of plastics. We have tested it for certain ones, but it works with the temperatures we have. We can work it for any plastics. And then also it's a hybrid technology with multiple nozzles, and it's a modular system, so you can actually replace or remove any system which you want. And then there is also another innovation on the software side. We have actually implemented a complete cyber physical systems with all the different sensors. We have around 60 plus sensors integrated into the system, which gives us real-time data.
Thank you very much. Now that you say about the any plastic, and I guess you use recycled plastic in some cases. So do you study the rheology of these? Do you study the rheology of these plastics? I mean, this material, to know which temperature are you going to set?
So one of the big questions which we want to answer with this technology is that how many times a particular plastics can be recycled. So it depends on where this recycled plastic is coming from. If it's a functional product from one industry to another, the rheology will be very different. So we cannot predict that at this moment, but we are mostly looking into kind of either PLA, ABS, and then kind of seeing if we want to recycle PLA and we can do it 6 times, can we enhance that and we can do it 8 times. So one of my master's students, he recently graduated in this topic. He was only looking into PLA, and we recycled it 5 times, and then we enhanced its properties to bring it to 7 times by adding of some additives and things as well.
Thank you very much. Another question for Dr. Alex? Yes.
I have a comment, yeah, and then a question. Okay. Regarding to the plastic that we recycle, our belief is that the material properties go down. But I may tell you that here in Tec de Monterrey, we discovered that it depends on the technology. We have been using the ultrasonic microinjection molding, and we found that, in fact, the mechanical properties increase even if you recycle the plastics. But in general, in the literature, then mentioned that. But now it depends on the technology. And the other question is regarding to multi-plastic material that you are using. I noticed that you are running uniaxial experimental tests, but based on the behavior of these plastics, I'm wondering, have you tried also to run what is the behavior of those multi-plastics by running tiered tests, shared tests, instead of uniaxial? Have you tried that?
No, that was just one project which we were interested in. So we have not done the test mostly on the functional product or a shear test yet. But I agree that those kind of tests would not work. It was a very simple way of how we can actually integrate multi-materials. But now with our technology, we can also mix materials because we have now powders or pellets and flakes available. So we can easily do those kind of tests on our system now. But I agree. And I completely agree with your first comment as well. It depends on the technology. With our technology, we have tested PLA recently, and we have found that the properties degrade. But with the additives, you can enhance the property quite easily.
Thank you very much, Dr. Ahmad.